equation, no? Because QP will be calculated only this by this scenario.
Hmm. Yeah.
Okay. If you
Okay.
want, if you want, what is the value of QP? Like for example, if I asking that what is the value of QP, so you have to try the expression. Then after the expression, you have to equate this equation with this standard equation, where you are getting the value of the omega, WP and QP.
Hmm. Yeah. Yes. Okay. Yeah. So this is something we have to remember, sir. Put it on our memory.
Which one?
This expression, the standard form of second
Yeah,
order.
standard form you have to use.
Okay. From here we can do our own calculations of the circuit and
Yes.
derive everything. Okay.
Any other? Any other doubts?
And sir,
Yeah.
in the filter concepts,
Yeah.
why we particularly or specifically take the 1 by root 2 value?
1/√2 value. Yeah.
Yes. What's so
Actually,
special?
basically, what we are consider that like when the transition will be done, no? Any for any case, not for the filter, when the transition will be done. Like for example, I'm just going from either from the maximum to minimum, okay, or from minimum to maximum. Okay. Always consider that the value of the duration will be lies from 10 to 90%. 90% and 10%. Okay. Always consider this value. Okay. Now, what we are taking the half power.
Okay.
Half power point. What is the meaning of half power? That means initially if the power P is the maximum. So what is the value of power should be P by 2.
Yeah.
Okay. Now if we are talking about the P by 2, this is the in terms of power. Now if I are calculating the voltage, so power is nothing but V square by R,
Yes.
and
Yeah.
for the normalized resistance value, the P is nothing but V square.
Yes.
If power is half, so that means P by 2, that means equal to V square by 2, V square. Okay. So what is the value? V is original value by root 2. Okay. V is
Okay.
equal to P1 is equal to V1 square. Now P by 2 is equal to V2 square. Okay. So what is the value of V2?
V square. V
Here,
by root 2.
yeah, V1 is equal to root of P1 and V2, yeah, root of P, and V2 is equal to root of P by 2. That means V1 upon root 2.
So when the voltage becomes root
1
2
by
of
root 2 times.
earlier one,
Yeah.
power becomes a half.
Yeah. If we are talking about the voltage, so V upon root.
Okay.
Okay. And why we are taking V upon root 2? Because this value is 3D.
Uh,
Okay. So it is also called the half power point. It is also called the maximum amplitude upon root 2 point, and it is also called the 3D.
yeah. Yes.
Okay. Because 1 by root 2 is what? If you calculate the value in in dB, so 1 upon root 2. So 20 log 10 1 upon root 2. That is what?
Um, 3.
Minus 20 log 10 root 2 or minus 10 log n 2.
Yes.
Okay, that is equal to minus 10 log 2 is 0.3010.
Okay.
That is 3.01 dB, or we can say that 3 dB.
Hmm. Yeah, yes.
Okay, that is called 3 by 3 names, half power point, voltage upon root 2 point, and the 3 dB point.
Log 2 is giving us minus 3.3010.
Log 2 is
What's the answer of log 2?
0.3010.
Oh, oh, that's a point. Okay. Yeah. Hmm.
Okay, and this one you are aware. There is no change, no issue in that.
No,
There is
yes.
no issue in that.
Yeah.
Minus 20 log 2 power 0.5. So what I do, minus 20 into
Hmm.
0.5 log 2. That is minus 10 log 2.
Yes.
And it is minus 3.012. So if I'm talking about the dB, so the value of dB should be lies 3 dB less with the maximum value.
Okay.
So it is called the.
Yeah, yes.
Okay, so that's why we are taking the half power point 3 dB point. Okay? Because if we are talking about the filter, either the standard filter is what, if I'm talking about the ideal filter, so ideal filter is what, like low pass filter, it will be 1 and it will become 0. So we can say this is the my cutoff frequency FC, because the frequency is single value. Okay. Now if we are talking it a practical filter, my practical filter will be like that. So it will be start reducing from this point and it will be go up to the 0 at this point. So this is the del F in which the transition is done. So it is called the transition band. Okay. Del F is the transition band. Now it is a quite typical for us that which frequency we call the cutoff frequency. Either this frequency, this. There are multiple frequencies. Okay, so what they
Yeah.
consider? They are taking where the magnitude will be half of that value. 1 upon root 2 of that value. Okay, so if the magnitude is different. And this is the V, so V by root. So we call them, this particular frequency is, this frequency is F.
So this is 1 by RC, right?
1 upon 2 by RC.
Yeah, yeah, correct.
Which type of filter is that? This type of circuit is that? According to this one, it will be changed, but
Okay.
it is a 1 upon 2 by RC. Maybe two resistors are there in parallel. So what I do, I am just taking the parallel RP multiply by C, the parallel combination of the resistance multiply by the C.
Okay.
This is all about it. If I have like, this is my operation amplifier.
So sir, the amplification done after that cutoff frequency is so negligible, is it, sir?
Like this is my circuit.
Yeah, I mean in this transition band, after the cutoff frequency, the frequency which comes after it are amplified only, are allowed only in a negligible amount.
Yeah, amplification is not possible after the frequency.
Yeah. Yes.
In the case of filter, we are generally discussing about only the frequency part. We are not talking about the amplitude part. Okay, the amplitude is the highest and maximum amplitude or the minimum amplitude. Okay, like we are drawing the circuit. So what is the frequency, cutoff frequency? Fc is equal to 1 upon 2 pi, the parallel combination of R1 parallel with R2 multiplied by C. So this is the Fc. Okay.
Yes.
Any other doubts? Yes, any other doubts? Again, it is a reminder that your quiz one is a subjective paper, pen paper. You have to solve the question on a sheet. After that, you have to scan it or basically submit it. There is no particularly computer-based exam. It is a pen paper.
Sir, what did you say? Could you repeat once again? Your voice seemed little low.
I just say that it is a week quiz one is the basically pen paper examination.
Okay.
Okay, it is not a computer based examination, it is a pen paper
Yeah.
exam. Questions are given on the computer. After that, you have to write the question answer on a paper and submit the scan copy. I think same day your analog electrics and DSP subject paper is there, no?
Yeah, yes.
And both are pen paper examination.
Yeah, yes.
Any doubt? Yes, any doubts? No doubt so far?
Sir,
Yeah.
uh, so we will we have a revision session on mock?
Okay. So can we do on the evening session on Friday?
Okay, sir.
Okay, Friday we have the live session, no?
Yeah, yeah, yes.
So can we do it as a mock, basically practice session? Because I think all are just read out the quiz for the quiz one. So and week four content we have already discussed. Okay. So I
Hmm.
think it is a better that we can cover the week one to four again without going to the week five.
Yes.
Okay. And probably either today or tomorrow I will share the quick mock paper with the Priyanka. Okay, so probably on today or tomorrow you will get the mock paper on your phone.
Yes.
Excuse me, sir.
Yeah, Krish. Yes.
Yes. Good evening, sir. Sir, actually, it would be great if you can give us the links for the recorded session because always we might not be able to join the live session also, as some of us are
Okay.
doing this as dual degree.
So,
So,
so basically, I am putting all the particular session on the YouTube. Na? Four lectures I have already uploaded on the YouTube. Okay, please share the channel link. Okay, I will share the channel link. Okay, but four lectures, yeah. Please share the particular link. Okay, this is a channel link. Through this particularly, you can watch the videos.
oh, okay, sir. Actually, previously it was showing unlisted, so I was not able to see. Okay, thank you, sir. Uh,
Yeah, I just convert into the listed part.
Sir, one more doubt.
Yeah,
For the analog lab, will any components be shipped to us, or should we do an LT spice only?
basically, I just put an announcement on tomorrow. Okay. Can you tell me at I think at what time tomorrow you are available? All
After 6:30 or 6 will be fine, sir.
can we do it at 10 to 11 a.m.? Is it okay? I think everyone will be free. Yes.
Okay, sir.
Actually, I will discuss. I will discuss with the professor first. If tomorrow we have a meeting, so after that I just put a message on this particularly G space about the timing. Okay.
Okay, sir.
Yeah, Akhilesh, tell me.
Sir, actually, I am not getting any mails or any update regarding this course, and I am not into that G space also.
Can you tell me the mail ID? Because that's why I'm. Wait a minute.
Yeah,
Yeah, please tell me your mail ID.
yes, 23F
Yeah,
30,000 24
3,000, 3,000, 30,000.
30,000 24.
24.
Yes, sir.
Okay.
Yes, sir.
Please check.
Sure. Yes, sir. I am. Thank you.
This is the basically G space we created. Okay, if I want to share, like I already shared the three books for the operation amplifier.
Yeah, that's why, sir, I am not getting any update or something like that.
Okay, okay,
Thank you
okay.
for adding.
No problem. Anyone also who are not added in the G space? Because actually I received the mail from the office. Around 60 mails I received, 16 mails. So I added all of them. I'm not getting the mails. Maybe you are registered late, later. That's why. Satyam, yes, Satyam.
Sir, uh,
Yeah.
could you upload the graded assignment solution on dashboard?
Yeah, today I will try to do it. Okay. I will try to do it today, third. Okay.
Yes, sir.
And, sir, if possible, professor lecture notes also, if you can upload.
Uh, okay. Okay, I will upload it that also.
Yeah, please.
Can I upload the professor lectures notes as a complete week, single week, a single lecture? Or it is visible?
Yeah, sir. No problem.
Any other things?
Sir, actually, I joined a bit late, so as I seen that you guys are discussing about the lab thing. So, what is the discussion? If you can tell me a bit.
Yeah, the discussion is that till now I'm getting particularly basically the one document to by the professor. Total six experiments are there in your in end of lectures lab. Okay. When I go through with the document, they are mentioning that you have to simulate as well as particularly perform that experiment on a kit. Okay, not any kit on a blackboard.
Okay.
Okay. So simulation, there are multiple softwares are available, but I just confirm once with the professor because tomorrow we have a meeting. So once I confirm with the professor that this particularly software they are using like Multisim, Proteus, LabVIEW, there are the three softwares are available. Okay, so out of these three, which software professor basically recommended? So we can do one thing is that you have to simulate the circuit first. Okay,
Okay.
on a software. Then after
Okay.
that, you have to particularly perform that circuit on a breadboard also.
And what about the parts? We will get it as
Yeah,
before, or we have to buy
yeah.
separately.
For that particularly part, I just see that components are not available because we are using like comparator, and one is the operation amplifier. Okay, so that component is not with you. So I have already discussed with this with the team. Uh, So they are giving me two options. One option is that either student can purchase it. Second thing, I can provide the list to them. They will talk to the vendor, and after discussing with the vendor will be delivering this particular component. Okay, two
Oh,
ways
okay.
are there. Okay, but I will confirm till tomorrow. Okay, because right now what we do is we have only getting we have actually I am getting only the six experiments, but these all six experiments are not verified. Okay, so if professor
Okay.
want to change, so after that after the professor will be confirmed, I have to prepare a list. After preparing the list, I give it to a team. Team will talk the vendor, and what the vendor will be doing will deliver this particular component to you. So it is a time taking process. It is a time taking process. So
So
the
actually, the
second,
thing is,
yeah.
I have to move to Kanpur, and that's why I have to arrange as soon as possible these things. That's why.
Okay. So the second thing is that I'm taking that if we get a complete list of the component that we are using, I will provide you the list. You go to the
Yeah.
local vendor, okay, and local vendor will be delivered to you in
Okay,
a
sir.
minimum time.
That would be great.
Yeah. But the problem is that actually one person says that in their city no local vendor is available to provide the components. So I have to discuss with
Uh,
the professor.
there could be an option like buying it online or something.
Yeah, that is the option. That is the option there, but it will be time taking, na? And week one assignment you have to submit till
Yeah,
30th.
that's also a thing. Right, right.
Yeah, right. So I have to discuss all the things with the professor.
Okay,
So
sir. Please
probably,
discuss and let us know what's the status of
yeah,
that.
yeah. Probably tomorrow we have a meeting. So that's why I'm taking. I'm telling that if the meeting will be done with the professor tomorrow, so can we schedule a live session where your doubts will be clear on tomorrow, because after tomorrow, day after tomorrow is not possible. Friday also we have a live session.
Right,
Saturday, if we plan the Saturday, because Sunday is your quiz examination.
right, right.
Okay, so probably if we have a discussion with the professor, after that I will schedule a tomorrow meeting. Is
Sure,
it
sir.
okay?
Yes, sir. Okay.
Okay, so basically for that I will create a poll on a G space. Please answer that. According to this we will schedule a
Okay,
meeting.
sir. Okay, sir. Thank you.
Yeah. Anything else? Anything else? Yes. Any doubt or anything else?
Sir,
Hmm.
I have a doubt in graded assignment week 2.
Week two, okay. Which particularly part?
Question 5, graded assignment.
Uh, yes, yes. Just tell me what is your doubt.
Sir, I'm getting something wrong answer. I think some plus and minus here. I have got some. So could you solve this question?
You are getting around 12 by 2. Yes. How many of you are getting the correct answer and wrong answer? Muthu, are you getting the correct answer or wrong?
Yeah, correct answer.
Okay, so now tell me.
Which question, sir? By the way?
Question number 5.
Uh, the output current. Right?
Yeah, output current.
Okay, so in non-inverting terminal we have 2 volts.
Okay,
So in the inverting terminal also we should have 2 volts.
okay,
Then we can apply KCL
okay,
and we can figure out what current will be I4.
okay. What current is I4?
Yeah,
Okay. So just I draw it here. That is a better thing.
and this is a summing amplifier, uh, right? But we have resistor on the
This is the circuit.
Sir, I think for this question, the I not, I'm not sure whether this is the question. I not is not given in the question.
I naught we have to calculate now.
Yeah, for one question in week 2, in
Yeah.
the diagram, I not wasn't mentioned.
The
Uh,
week to
I
one
mailed
question.
you and you sent me the correct diagram.
So I just correct this one, na? This is the correct diagram.
Oh, yeah, correct. Okay, yeah, yes. Afterwards, yeah.
So yes, tell me. So this is the 2 volts.
Yeah. 2
This
volts.
point is
So,
2 volts.
yeah,
This point is also
2 volts.
2 volts. So if I apply the KCL, so what will be happen?
So, 2, 2 minus 0.1 divided
0.1
by 10
upon 10K.
plus 2 minus 0.2 divided by 20.
I think we have already discussed this question.
40 plus,
That is equal to.
so we can also add a plus, okay, it also VO minus 2 by 30.
So what is the value of V naught?
We can make it 120 kVm.
Mm,
So
22 by 8 plus 10.8 plus 4.8 plus 8. So V naught is equal to 52, 40, 44, 46.4 divided by 122. The value is 0.38. Oh, sorry. That is V naught by 30. V naught by 30 is this one. What is the value of V naught? V naught is 11.6. So this is your first question, 11.68. Okay. Now in the previous figure, the output current I know this. Now, as I know that I4 plus I naught is equal to I. Okay. What is the value of IL? V naught by
and
15K.
6. Yeah, yes.
What is IL?
I
V naught minus 2. Sorry, 2 minus V
IN is
naught.
the V naught by 50.
I4 is 2 minus V
0.3.
naught divided by 30K.
We can put 0.38. Okay, that is about it.
Plus I naught. Okay. 2 minus, because I4 current is that is coming from this side. So I am taking that this is a 2 voltage, the 2 to V naught is the current will be flowing. So that is the value of I4. Okay, so 2 minus V naught by 30K. Okay, now V naught is 11.6. So I can put the value of this one, 2 minus 11.6 upon 30K plus I naught is equal to 11.6 upon 15K. So I naught is 11.6 upon 15K plus 9.6 upon 30K. Take the LCM of 30K, that is 23.2 plus 9.6. It is 32.8 upon 30K. 32.8 upon 30K. That is 1.09. Okay, so this is the value. Yes,
Sir,
now it's, yeah.
in first line from
Mhm.
starting, Could you scroll up?
With in okay, okay,
Uh,
scroll up.
First line. Yes, sir. In KCL equation, we write 2 minus V naught by 30k or V naught minus 2 by 30k.
Mm, V naught by minus 2 by 30. Wait a minute. Actually, what is the thing is that basically the current from the 30K will be going this direction. Okay. So the current is coming from this direction. So the current will be distributed in three branches. So what I do, I just take a incoming current, that is the V naught minus 2 by 30K, that is equal to the all outgoing current. Okay. Otherwise your equation will be what? If I say this is the I1, I2 and I3. Okay, and this is the I4. If you are taking, this is also a outgoing current. So your equation is I1 plus I2 plus I3 plus I4 becomes 0. I1, I2, I3 both are same, all are same, this one, this one, this one. And what is the value of I4? 2 minus V naught upon 32. That becomes 0. Okay. If you take this side, so it becomes minus is equal to 0. And minus V naught and minus 2. So become 2 become this minus minus become plus. So it becomes 2 and minus V naught. So 2 minus V naught upon 32. Okay, so you can write it anyway.
Yes, sir.
Sir,
Yeah.
uh, we can also use summing amplifier formula also, right, for making
Yeah,
the
yeah,
calculation.
you can use the summing amplifier formula also.
Yes.
So which type of this particularly is this one? Like if I am saying that this is the negative. So what is the summing amplifier formula?
Minus RF by
V
R,
out is equal to V is equal to minus RF by R1 into V1 minus RF by R2 into
V2,
V2 minus RF by R3 into
V3,
V3. You can use this formula to calculate the V naught. After V naught is calculated, you can calculate the I naught.
I4 and IL.
Yeah. Okay. So anyway, you can use the answer will be same.
Yes, sir. And sir, in question 8 also, I have doubt.
Hmm?
Question 8.
Question 8 of the same assignment.
Yes, sir. 7, sir. 7. Question 7.
Questions. This one.
Yes, sir.
Okay. So what is the doubt in this one?
I'm getting wrong answer.
Consider circuit shown below. If V1 is 4 volt and V2 is 2 volt, the current mark I naught is 1 milliampere. The value of resistance R is 25. So So this term is my V2. This is my V2. This is my V0. Uh, we are getting the V1 is 4 volt and V2 is 2 volt. I think this is the question Muthu where we are not having the value right now. I noticed one
Yes.
million answer. I noticed 1 million answer. After that the question will be correct now. I think I changed the question. I have changed the question or not on the portal?
No, sir, not yet. I just shared it on the WhatsApp.
Okay. So I noticed 1 million. So I have to share this one. Okay. So V1 is 4 volts and V2 is 2 volts. Now how can I solve this one?
Sir, I think I naught is coming
Ye-
into the amplifier.
yes. It is coming inside. I think this is the direction of I know. Yes, it's fine.
Yes.
Okay. So now tell me.
Sir, could you explain the direction of current why you did Q0?
I have mentioned this one. I noticed 1 million. Where I get the particularly do this.
Excuse me, sir.
Yes.
Sir, for the week 3, actually, in one question, the answer was given as non-terminating terminal. I think in question
No
7.
inverting terminal. Non inverting terminal.
Yes, sir. In that, I had kept the answer as the symbol plus, which also
Okay.
means non-inverting. But it has given me the wrong answer, and marks were not awarded.
Have you checked it again?
Yes, sir. Just 15-20 minutes back only I checked.
Okay. Basically, that particularly question will be removed from the marking. Okay.
Okay, sir. So in the final marking, it will be changed.
Yeah, probably it will be changed on your portal. I don't know why it is not done, but I have shared with this with the purpose.
Okay, sir. As of now, it is not updated. Maybe after once they update the final marking, it may get updated.
Yeah.
Yeah. Yes, sir. Even the other questions too.
Yeah, there are changes in the questions. I just tell in the previous class that I have to change a answer of 3 to 4 questions.
Correct. Yes.
Okay. So the particularly it will be shared with the team. So team will be updating. Okay, and you just receive a mail that your score will be updated.
Okay, sir. Yes.
Thank you, sir.
Okay. Yeah. Now how we solve this one question? This question.
Sir, are you sharing your screen?
Just wait a minute. Yes, how we solve this question?
Okay, so the voltage is
Satyam, you are asking this question?
Yes,
Satyam,
sir.
so please tell me
Yes,
what
sir.
is your what approaches you are using. So we will check that. What is the voltage at the positive terminal? This one,
V V2.
V2. So the positive terminal we have the voltage as V2. Okay, V plus. So that means what is the voltage at this point? V2 voltage.
Yes, sir.
Okay. Now if I say V1 and and because of this V1, what is the voltage we are getting across this resistor? So if I say the V2 voltage is nothing but V1 into 4R upon 5R. Please check it is correct or not. Just okay. So what is the output voltage in this? What is the output voltage? If I say this is the voltage of VA, okay, this point voltage is VA. This point voltage is VB. So what is the voltage VA? Yes, the voltage of VA is nothing but the voltage drop across 4R resistor. This 4R. So VA is equal to V1 into 4R upon total resistance is 5R. Okay, so it becomes V1 is 4 multiplied by 4 upon 5. That is 16 by 5. 3.1 volt. Okay, VA is 3. Okay. Now if VA is 3.1 voltage, so what is the output voltage? VA minus V out upon 2R. That is equal to, yes, what?
sir,
Yeah.
the VA will also be affected by the feedback resistor also.
VA is also affected by the feedback resistor. Yes, correct.
So it just VA is it will it still be 3.1?
If I put it as a VA here,
Then so the KCL needs to be done to find the exact VA.
okay. So I just put it as a, this is my VA and this is my VC. Is it? Is it okay?
Yeah, yes.
So what is the value of VA? Now 3.1. What is the value of VC? Similar to VA. Why? Because we are not having any voltage drop between VA and VC. So the voltage at VA is equal to the voltage at VC. So what is the value of VC? VC is again 3.1. Clear? Yes, Muthu. Clear?
Yes, sir.
Now, yes, what we can do here?
Sir,
Yeah.
why we don't say VA as 2 volts?
Why we don't take VA as a 2 volts?
Yeah, yes.
Why we are taking the VA as a 2 volts?
Because it is a negative feedback is there, and
This voltage.
yeah, it is 2 volts, so VA should also.
It is a 2 volt. The voltage drop across this one is the Vx. So 2 minus Vx is equal to Vb.
But here the voltage won't drop, right? Because current, it is an ideal op amp.
Yeah.
So VA, I mean the voltages are negative, inverting terminal and non-inverting terminal will be 2, right?
Okay. So you are saying the Vc and Vb both are same.
Yeah, and both are equal to 2.
Okay. But the voltage drop across this point is what?
Um, that will also be not. It will also be 2, right? VA is also 2, right?
So if we are taking VA as a 2 volts, right? So VA as a 2 volts. So now what? Now
Now we
solve it.
can KCL.
At what point?
Yeah, the VA point.
VA point. So if I say that current is coming from this direction, it will be going to this direction, and it will be going to this direction.
Yes.
Right? So V1 minus VA
Yeah.
upon R, that is incoming current, is equal to outgoing current. So VA upon 4R plus VA minus V
Yes.
out
VA
upon 2R.
2.
So R and R cancel out.
Yeah, yes.
Okay. So that 4 minus 2 is equal to 2 upon 4 plus 2 minus V out by 2. Okay, so if I take the LCM, 8 is equal to 2 plus 4 minus 2 V out. Okay, so minus 2 V out is equal to 2. That implies V out is equal to minus 1. Okay.
Yes. Yes.
Now, if I am talking about the current, so current at this point, this is the incoming current, this is the outgoing current, and this is the outgoing current. So
Yes.
incoming current is what? VA minus V
Yes.
out
Yeah.
divided by 2R
So
is equal to,
equals I
what is the
naught
value of I naught? I naught is 1 milliamp
1 MV.
plus V naught by R.
Yes.
So I put the value. VA is 2 volt 2 and V out is minus 1. So 3 divided by 2 R equal to 1 milliampere plus, sorry, minus 1 by R. Okay. So I'm taking out this side. So 3 upon 2R minus 1 upon R is 1 million. Take the 2R LCM. So it is 3 minus 2 is equal to 1. So 1 upon 2R equal to 1 million is equal to R is equal to 1 kilo. R is equal to 500. It is not a correct. I do understand here.
Sir, till V naught equals minus 1, everything is correct. Um, so I got V naught 2R equals 5.
Yeah.
Yes.
B is equal to 2 plus 1, 3 upon 2R and this 2. Oh, sorry, this is a plus.
Yes.
It's a plus. So it becomes 5. So the value of R is 5 by 2 kilo. It is not equal. Okay.
Yes. So the second last line is 5 R equals 5 by 2, right, sir?
Yeah. R is equal to?
5 by 2 K ohm, right?
Yeah.
The second last line.
Yeah, this one 5 by 2 kilo. R is equal to.
R equals. Yes.
Layout is 1.3. So now check. Okay. Yes. Yes. Okay. That is RS25. Yes. Any other points?
No, sir.
So I think we will stop here. Thank you all. Okay,
Thank you, sir.
I will schedule basically on if tomorrow will be have a live session of the lab.
Yeah, yes, sir.
Thank you, sir.
Yes. Thank you, sir.
Thank you, sir. Good
Good
night.
night.